All right. Thank you very much, Tayab. I really appreciate it. Thanks for having me here today. These events are really fun. I love the feedback. I love the ideas. I love the way this works. I really enjoy this. As an aside, for virtual events, if you can't choose between 3 sessions, I highly recommend getting 3 screens and setting up all 3 at once and listen to them all at once and see what happens to your brain. But enough of that. This is a cool session. This is fun. This is not as tech heavy as some of the ones that I present where I have like tens of thousands of lines of T-SQL and code and stuff. This is very much about taking different areas of the world of software development and administration and merging them all together. Basically, administrators and operators very often will collect data, all from their servers all over the place, and use it for monitoring and alerting and things like that. Those important operational things that you can't live without. But what I really want to talk about here today, the whole point of the session is to take that and go further with it. Identify metrics that are useful, and then find ways to analyze them. So perform analytics on them, architect places to store them, and really take all these areas and put them together. So this is kind of a fun way to merge together all of our jobs into one and kind of work together on a neat solution to a problem that otherwise is pretty hard to solve. But first off, really quick, this is me. I've done a lot out there. I've written books. I've run SQL Saturday Albany. I've been to lots of events. I'm actually currently in the works of publishing a new book on column store indexes in February-ish. Keep an eye out for that. Got a kid's birthday coming up in a few days. Should be exciting. Cupcake everywhere. Yay. But anyway, that's me. Feel free to contact me on Twitter. My info should be on the Future Data Driven site as well, in case you want to locate me. Any ideas, feedback, thoughts, questions, answers, criticism, whatever, just let me know. And with that, let's go. So the title of this is almost a little weird. What's a database metric? What do I mean by that? And this is intentionally very generic. But basically, this is metadata about your database, about the place you store it. So you have an application, it stores data in a database somewhere. It could be small, it can be large, it could be transactional, it could be analytic, it doesn't matter. But you have data there and it grows over time. And you might keep some metadata about that. Those are counts, they're calculations, and they ultimately tell you about your database, about the server that hosts it, and about just how this data grows over time. Is it healthy? Is it not healthy? Is it valid? Is it invalid? Is data quality high or low? How much of it is there? These are all database metrics. It's a very generic definition, and much of what we collect about our data falls into this category. The point of this is to save this data, not temporarily for the purpose of alerting, like, hey, monitor this. If you ever see a deadlock or a blocking problem, memory is getting low, let me know right then and be done. That's what alerting and monitoring is. Alerting and monitoring is all about I want to know something right now, see if something's wrong or not wrong, and let people know immediately. And then they resolve the operational problem and life goes on. What I want to do here is introduce the idea of saving all this data long term. So don't just look at it briefly, analyze it, and say, all right, problem solved, move on with life. I want to save this long term. I want to save data about our data, metadata, for months, for years in a central analytic repository. It can be a table in SQL Server with a column store index. It can be in Tableau or Power BI, wherever you want to put your data, wherever your analytic data goes, put this data there. And what can we do with it? So we take metrics data, and I'll have some examples of that coming up soon. Feel free to put into the chat any thoughts you have, any ideas. I'm happy to stop along the way and talk about them. So with this data, what we're trying to do is predict the future. And we save it long term, so we have lots of history to go on and lots of future to look forward to. And we can do a lot with it. With data about our data that goes back far, we can say, hey, let's look out for application bugs, because if anything strange happens long term, not a point in time, but something happens over the course of a few days or a week or a month or a few hours, we can say, hey, that points to a problem. What happened around then? Was there a new software release? Somebody push a change? Did we turn on a brand new feature that we had released a few months ago? We flipped the switch and now something's happening. Did some other change occur, or did no change occur? And there's some natural thing that occurred over time that just time allowed to happen. We can predict capacity problems. So everywhere you look, you have a limited amount of capacity that you assign to your data. It can be storage, it can be memory, it can be CPU, it's your compute. And you want to be able to predict the future of that. You want to be able to say, this is what we're using now, here's what we'll be using next year. And then along the way, when things change, you want to be able to say, uh-oh, something changed. Let's just redo that future so we know where we're going to be in a year from now, because a lot of this has to do with budgeting and knowing what resources we need to get and who to ask for them. You can't do that at the last second. If you call somebody up and say, hey, I need a terabyte of space and another like 100 gigs of RAM now, can I just have it now, please? They may say that's okay, or they may laugh at you and tell you to go home. We can find bad data, and this is key. This is hard to find. Finding bad data is not easy because very often we look for bad data, we're looking for the bad data we know about. Like you'll say to yourself, hey, I know that if I see this, this, and this right now as it comes into the database, it's bad. And that's great, again, operations-wise, because you're finding something as it happens. But over time, bad data can be created as well, and you may not be able to see it by looking at a single data point. So by collecting metrics about your database and your data over a long period of time, you can identify bad data, things that are growing in unhealthy ways, or shrinking in unhealthy ways, or missing data, or too much data. Things like that are hard to find as a point in time, but they get easier over a long period of time when you can identify what's normal and not normal. And because of that, we can identify performance issues. Performance issues, again, are very obvious when they happen live. Someone calls you and says, hey, the database is slow. And you say, what do you mean by that? And you have that conversation. Great conversation to have, right? But that's kind of the last resort conversation because now everyone's in a hurry. My thing is slow. You've got to fix it. Fix it right now. I'm going to sit here with my arms crossed and wait. And we're all very unhappy. What we really want to do is identify these problems before they happen. For example, maybe a table is growing unnaturally fast, and I see that rate of growth, the acceleration of growth over time, and it begins to increase. It may not be the sort of thing you would notice day to day, but over a long period of time with some trending, you would very easily catch and say, hey, this is going to get slower and slower and slower until we're in trouble. Let's figure that out now so we don't have the uncomfortable 2 a.m. phone call later. And the biggie here is we can use all this data to identify anomalies. This is really where all the analytics and the machine learning and all that fun stuff gets into here, where you can really flex your BI muscles and your analytics muscles and have fun. So we're going to say we have all this data. We have years and years worth of data here about our data, metadata. And we can understand based on that, because there's so much of it, what normal is and what not normal is. And then based on that, we can say if certain conditions are met, that's not good. That's anomalous, it's unusual, it's unnatural. Let us know about that so we can investigate. And as a side note in this presentation, everything I'm talking about here, I've implemented in production environments in some fashion. So what I'm talking about here isn't a hypothetical. This is a real thing that can be done, and the effort isn't immense to do it. And the number one key here is that now is better than later. When you're looking for problems, you want to find the problems now. You don't want to discover them when it's too late, because when it's too late, you may not be able to fix them quickly enough. When you have weeks to figure it out or months, that makes everyone happier. And you look better, you feel better, your life is better, your job is better, because each one of these things that you find is one less wake-up call in the future for you or somebody else. And you should brag about it, of course. Everybody should know when you do things like this because it's awesome. So the first and simplest and probably one of the most valuable examples of a way to use database metrics in a production environment are row counts. This is very, very simple. You simply go in your database and you collect the row counts for all your tables. Done. You can go more granular if you want. You can do row counts by partitions and things like that. But ultimately, this is telling you how big is your data. If you want, you can very easily include data size in here. DMDB partition stats is a view that has that inside of it. I'll have a demo of this shortly. And this tells you how big your data is, how many rows are in your table. And it's very, very easy to report on, very easy to store. It's not big data. Even if you have millions and billions of rows, it won't take up all your storage. It's small stuff. And you can trend it over time to see how your data grows. The size of your database is one thing. That's useful to trend, because knowing how much data is used is valuable. And if it goes up too fast, you've got a storage capacity issue, potentially, memory issue maybe. But row counts tell you about each individual object. So your application is throwing data into tables in a database, and there could be 10 tables, 50 tables, 1,000 tables. And this helps you figure out which ones of them are growing. And you can very easily say, what happens if a table is growing too fast or too slow? What if no rows went into a table over the past day that should have? What if this table typically grows at about 2% per day every day, and suddenly after a release it's at 50% or 20% or 0? This is the sort of thing you can look for programmatically. All these things I'm talking about today are automated. We don't want to do this by hand. Research is done by hand. Implementation should be automated. And so all of these metrics we're going to talk about should be automated. You should program the stuff implement it, and walk away, and then you'll do nothing until a problem comes up, and ideally it'll let you know there's a problem. Things we can find out with row counts are like missing retention. Maybe we've added a brand new table. Has anybody experienced this before? You've added a brand new table. You started populating with data an hour later, and somebody forgot that piece about the, oh yeah, we don't need data older than a month. And so the data begins going in the table, everything's great, nothing's wrong, and then like 9 months later, you have a billion rows, and things are kind of slow, and the database is getting kind of big and sluggish, and somebody begins asking, what's going on here? Why are things getting slow? Why is the database so big? Why are people complaining about latency, inserting some new stuff? And then you discover the billion row table that should only have 100,000 rows or something, and you say, oh, whoops, we missed that. Sorry about that. Let me go out there and delete a whole bunch of stuff now and cause some havoc. But it could have been noticed because you would have seen a table growing unbounded. And at some point, you would have had some alert going off saying, hey, is this table supposed to be this large? Is this normal? It doesn't seem normal. Tables shouldn't grow unbounded forever unless they're, built to do that. And it's a new table. So you can also flag a new table as being special. You very easily could say any one day of the week, hey, here's a set of tables that came in today with row counts. Here's a set from yesterday. I see 3 new tables that were not there yesterday. Let's keep an eye on those. Put them on the special list automatically. Keep an eye on them for 1 month and see do they grow normally, or 2 months maybe, depending on how your retention works and how your processes work. And then ultimately, you can compare different tables across an organization. So if you have one giant database, one set of tables, you can keep an eye on that, and that's great. If you have multiple databases or many databases in a kind of a multi-tenant sort of environment, where maybe you have 100 databases, all the same schema all over the place, you can compare all of them together, aggregate all of them, and talk about them as a group. And then figure out which ones are efficient, which ones are not. Why are some better than others? Are we unbalanced? Are there too many resources here, not enough here? A lot of questions you can ask. And trending this over time is the win. Keeping this data for a little while is great. You can always keep 1 day of row counts and answer anybody who asks the question, hey, I'm just looking for the database, the largest table for this, or I'm looking for the biggest or smallest of this. That's easy. Anybody can answer that. But when you trend it over time, you get value. You can say, I want to establish a baseline over the course of the past month, and then look forward for the next week and say, are we on that baseline? Are we below it or above it? Is it normal? Is it abnormal? And go from there. So let's kind of demo very briefly what data I'm talking about here. And I've already created some of this already to save some trouble. So I create a very basic table here called row count historical. Now notice I page compressed it here. You're gonna have to be really big, 5, 10 million more rows, whatever. You can column store index it, get better compression out of it. That's always a good idea. But for now, it's page compressed. And all this is really is just an ID, a sample time, database schema, table, row count done. Very, very simple, very basic, nothing huge here at all. And this is where the data is going to go. Done. I now make a proc called collect row count metrics. And this is, again, nothing complicated here, nothing wild. It's a simple data collection proc. It should be reminiscent of any kind of data load process you might have, where you go in, you get the current date, delete your data from today in case you're running the data load again, and then we iterate, in this case, through every database in the server and grab all the data out of sys.dmdb partition stats. So this proc is specifically going out on a single server, getting every user database, and then grabbing all the row counts for all the tables and plopping it into a temp table, into a permanent table here, the row count historical table, and then your data is there. Nothing complicated here, really straightforward. Create the proc, not a lot of lines of SQL. The dynamic SQL is a little funky, but it looks like SQL, and all we're really doing is just querying some system views. DMDB partition stats can provide you with row counts and size information. Very useful view. It's an estimate technically, but it's a very good estimate. Within a tiny, tiny fraction of a percent, it'll usually be right. And you use that because doing counts out of tables is expensive, and you don't want to do expensive things in production. And then we just join a few other views to get back the object information, the schema information. Done. And I'll skip the system databases because in this case, I don't care about them. If you care about them, feel free to grab them. In my example, I don't care about them. And then I go in and I run it, and it's pretty fast because these views are not slow. And I look at my table, and what I see here is I can see the last few times I ran it, and I see today's data. And all I see is just the ID, the date, the database name, schema name, table name, row count. Done. This is key. This is the beginning of something really cool. And Once you've done this, you can collect it every single day and begin comparing today to yesterday or today to last week. As data goes larger, you may want to create a delta table perhaps that has the differences over the course of a day or a week or a month or whatever, but you may not need that. You can very easily take this data and join today to yesterday, look at the difference. Today to a week ago, look at the difference. Get the average rate of growth over the course of the week. Give me the deltas for all 7 of the last days. Average them together and tell me this is my average growth. Now look at the next few days. Is it bigger, smaller, normal, not normal? So much of this is really about normal versus abnormal. If this gets very big, because this could theoretically get very big, my local server here isn't very big. I got 427 rows back, which is not a huge deal. But if yours is too big, you can always consider getting rid of tables with less than a certain number of rows because maybe you don't care about them. You may have tables in your hand that have very large data, very small row counts. Those you might care about. DMDB partition stats has table size as well. Feel free to use that if that's helpful to you. You can add that in very inexpensively. You can chop out the tables you don't want, don't care about. Slowly changing fact table, as weird thing as it sounds, you can do that as well and say only give data in here when it changes. When it doesn't change, do nothing. When it does change, put a new row in and you have your start date, your valid through date, done. Slowly changing dimension table, basics. And then filter out anything you don't need. And once you have this data, what do we do with it? We look at it day over day, week over week, month over month, whatever, and ask questions about our data. And some of these questions you'll think of up front, implement, and you'll save your own butt frequently, and that'll be great. Saving your butt is a good thing. Or you'll have something happen in production that you didn't know about. It'll introduce you to something that is abnormal, and you'll code that into your validation process to say, hey, I know going forward that tables of this form should never grow by more than this percent or this many rows per day. Therefore, if it does, send off an alert, let me know, and I'll deal with it. Great. And again, row count changes are important. Big increases, big decreases. No change can be bad. If you have a table that stops growing and you think it should be growing, that's bad. And thresholds and ultimately normal versus abnormal. So lots and lots of ideas here. A key to row counts, though, is that row counts don't quantify updates. So if you issue a ton of updates against a database, row counts won't change. This table will not help you with that. This talks about inserts and deletes only. And so it's telling you how your data is growing or shrinking in terms of depth, not width, and not change. So if you have out of control updates, this won't help you, but we can look at different things that may also help you there as well. Cool. So those are row counts, and it's a very simple metric, very easy to track, very inexpensive to track, but very, very useful. Probably one of the most useful things in my career I've tracked and analyzed and just thrown analytics at and gotten back crunched information about and alerted on is row counts. I've personally been witness to production bugs get caught early and fixed, and no one ever having to know the hard way what that bug would have been like had no one caught it. We've caught bad data, no data, invalid data, billing issues, all kinds of scary stuff that if left unchecked results in headaches for an organization. But when caught early means minimal hassle or no hassle. And that's awesome. So what else can we track? That metric row counts really talks about the size of your data. How big is it? Is it 1 million rows, 1 billion rows, 1 trillion rows? How much is it? How large is it? How many megabytes, gigabytes, terabytes, petabytes? That's what row counts and the associated data you can grab alongside it can tell us. This gives us the other aspect of it, database I/O. Again, this is something that people very often track as an operational stat. I want to know how much I/O my database is doing, and if it's too high, let me know, because I know for a fact that my storage system, wherever the heck it's located, can only handle so much I/O, and if I go too high, there's going to be some threshold I'll hit. I can only push so much data from storage to memory, and only so much data from storage to the server. So there's limits, and those limits are important, and knowing how it grows over time tells us how we approach those limits, and also just how active is our database and what's normal and bad. So database I/O measures your activity per database file. You can go out to DMOS volume stats, and you can find out your I/O activity per database file. And that tells you reads, it tells you writes. And that is very, very important because you know how active your database is. This is the other dimension of things. This is the people inserting, updating, and deleting data in your database. It doesn't tell you very much, and it tells you your selects too. You have reads. So it can isolate periods that are busy, periods that are unusually busy, you can just quantify your overall I/O over the course of hours, days, weeks, and you can then use it for a lot of purposes afterwards. It could be used for troubleshooting, of course. If I/O gets really high and things are slow, we can find out what database file at least it's in to give it a little bit of idea. Is it a data file or a log file? Useful information. And which database is it happening in? Also useful. And you can trend it over time, like everything else. The value here is always going to be in trending this data over time. Keeping it for months and years is very, very good. Keeping it for days is not as useful for what we're trying to do here. And ultimately, you know how things grow over time. So like before, a lot of the same theme. We're going to collect this data, keep it for a long time, and then analyze it, looking for trends, and then identifying things that break those trends and alerting on it. And so these alerts are going to be very different flavors of alerts. It won't be the sort of alert that says 2 a.m, server down, panic, or the network isn't responding or something. This is it's 9 a.m. in the morning, I got a friendly email, and the friendly email tells me, hey, some weird growth was identified here. You should look into it. And you say, okay, let me have a coffee and look at this growth. And you say, wow, it's a little weird. Let me investigate. Oh, yeah, that could lead somewhere bad in 2 weeks. Good. Notice the difference. Instead of 2 a.m. panicking and peeing yourself, it is 9 a.m. with a coffee. It's much better. Let's take a peek at this data and what it looks like. So I'm going to create a brand new table very similar to what we saw before, IO virtual file stats historical. And we're going to take a look at, put a date in there, database file, file type, physical name, and then reads, bytes read, writes, bytes written. And again, I compressed it with page compression. If your data is going to get monstrously big for any reason, feel free to column store it and call it a day. But basically, it's just going to be 1 row per unit time. Now, I did a date time here because this is the sort of thing you may want to track hourly. Maybe more often, maybe every 10 minutes, but typically hourly is what a lot of people like to do for this because we can get a little bit of granularity over the course of the hour. So we know what like 7 a.m. is like versus 9 a.m. versus noon versus whatever. You need a little bit of time zone sensitivity there. If you have servers all over the world, you can then change this over to a date-time offset or UTC or whatever, and then store that neutral data in there. I do UTC here. You can handle your time zones however you want. That's your business, not mine. And then we build a proc very much like before that will get me the current time. And then insert into my table data from sys.master files. Now note here I don't have to do dynamic SQL. This is just master database views, and I can just go grab this data, look at it, and life is good. So I'm going to grab master files to get a list of database files, and then I will look at DMIO virtual file stats, no parameters needed, and this will then enter to the database for more information, and then I get back data. So I think I've already created this, but I'll just make sure I did. Great. I'll execute it, and I get some data back. And you can see here is my current data that I pulled right here. I can see I have database name, file type. Is it a data file or a log file? What's the physical name of the file? Where is it located? You can see I have some NDFs here, some LDFs, some MDFs. You could very easily add some more detail to this if you want. Check the extension of the file. NDF is an extra data file. LDF is a log file. MDF is the primary data file. You can do whatever additional metadata on this metadata you want. And then I grab number of reads, number of bytes read, number of writes, number of bytes written. Now note, an important key here is that these values are cumulative for this counter. So if I take this again and run it again, for fun, I'll just run it again right now, and look at it, you'll see the values haven't changed much. That's okay. For example, this here had 61 reads, and now it has 65. It's cumulative. So I need to do a diff over time between 2 points in time to get what the actual number of reads and writes were over the course of the time period between when I took a snapshot now and a snapshot the next time. So that's key. And the snapshotting isn't very hard. You run this as often as you want. It could be every minute, hour, day, whatever. And then all you do is just grab the most current point in time, join it to your last point in time, perform the difference, and you're done. That tells you how many reads or writes there were. And these are really useful metrics because, again, you now find out over the course of any one unit of time how many reads, how many writes, bytes, and you now know how much data is being written to each database, and in aggregate, your whole server. This is the sort of data you probably do want for your system databases, even if you don't necessarily care about it with respect to your application, you should care about it here, because you'll know that if MSDB is very, very busy, it could be a backup issue going on maybe, or some SQL Server agent job gone awry. If you have a TempDB database that's going crazy, too many reads, too many writes, well, maybe something is using too much TempDB resources. You should look into it before something bad happens. You don't want TempDB running out of space. That's bad. You don't want to be hitting up against limits there, because when TempDB runs out of space, things break, they stop working, queries get rolled back. Nobody likes that. Transactions don't like being rolled back, and neither do you like seeing that happen. So certainly grabbing this every unit at a time, every so often, regularly, keep it, trend it, diff it, look at it, and then look for changes. You know very quickly what this will look like at any given point in time, whether it's hourly or daily, and you know when it's different. So if you know every day 9 a.m. is your peak period where it's most busy, and a day comes up where it's 30% lower reads than usual, and it's not a weird holiday or something, you may say, hey, that's strange. Why is that happening? And as an aside, if you're thinking about, well, how do I account for holidays and special days and dates and things like that, where our usage might be different because of the state or the nature of our business, you can solve that with a calendar table. If you join your data into account, any of these metrics that we're talking about here, join them into a calendar table that has one row per date going from 1980 through 2100 or something. And then you can then tag the days with holidays or special dates or business dates that are unique to your organization that don't necessarily apply elsewhere. That way you can then say, hey, when I do my measurements here, I know holidays will be higher or lower depending on organization. I can account for that. So just random fun tip, you can join into a calendar table. I have a series of articles up on calendar tables. Feel free to look them up. Edward Pollack calendar tables. Have fun. Could be a useful thing for analytics and trending to know that certain days are special, and your analytics may not catch that because those days may only occur once a month, once a year, once a quarter, and therefore you may not notice it for a while. But knowing up front that's the case will save you a lot of worries later. Other thoughts here really are just you're looking to identify trends of unusual things. And one key about this data too is that IO stats will not pinpoint your problem. Table growth gets you closer. IO stats will tell you basically what database and what kind of reads and writes the problem. But then you at least know there's a problem and you can look for it. Not knowing there's a problem, you can't look for it. When you know there's a problem, you can just begin searching for it and finding it, taking measurements, looking at queries, looking at stuff in the cache, whatever you got to do to find your problem. That's the operational side, and a big part of operations is knowing there is a problem, and then you can go chase the problem. Cool. So one more example here before I get into the laundry list of all the thoughts and ideas and ways of making this better. This is even more operational one. You may be asking yourself, oh wait, blocking and waits. This is like administration 101. We check for that when they get serious. I get an alert. If the waits on a server in a certain database or process get over a certain number of seconds, I get an alarm saying, hey, too many waits, something bad is going on. But those, again, are operational concerns. We care about them, but I want to look at over a long period of time the trending of this data. What happens when I take blocking and waits and I look at this sort of data over days, weeks, months, years? What I establish is averages and sums. I know in aggregate how much waits do I expect to see every unit time, how many waits, how many waits of each type do I expect to see. That's useful. You can break it down by type if you want. That way you know if a certain type of wait begins increasing over time, unnaturally you have an idea what to look for. If it's locking, for example, or deadlocking, you have a code issue somewhere that's probably worth investigating. If it's like, a page IO latch, maybe there's some issue reading data into memory. Maybe you need more RAM, or you need, faster storage or something. Who knows? But the type of wait may give you some ideas. If you see like, CX packet waits, maybe it's parallelism. Somebody bumped up MaxStop and bad things happened. I don't know. These may or may not be real issues, but they're potential issues, and you can look for them. So you can find queries that are getting slower over time because the wait stats contains a wealth of information from query details to execution plan details to IO, CPU, memory, contention, wait times. I mean, this is just, you can go out to the sys processes and DM exec requests and get out just a plethora of operational information. But then when you throw that into a table and store it long term and compress the SNOS out of it, what you get is analytic data that can tell you a lot more than just operations. It can tell you how is your application performing over a long period of time. And some of those monitoring apps out there that are pretty cool do that. They grab all this kind of data, they throw it into a database, they compress it heavily, and they analyze it and let you know about problems. And that's great. And as addition, in all this data, you can find out who did it, what app did it, what program did it, what connection, what IP address. The volume of data located in these system views is pretty massive. And so once you're grabbing it and storing it and trending it, looking at deltas over time, you can really do a lot with it. And knowing resource pressure before resources run out is really huge. Being able to say, hey, I see this doing this, and we have this much time before we're in trouble and see actual production problems. Let's find the problem before we get there, or add resources. And very often, if you go out there and say, hey, help me find this problem or spend $1 million, they'll probably help you solve the problem because it's superior to spending $1 million. Although maybe not everybody agrees. So this really, the key to this is that weights are not just for monitoring anymore. We think about them as a monitoring issue, but it can be a long-term trending, capacity planning, anomaly detection thing that's kind of cool. And so again, like before, I'm going to provide a query that shows how you get this data. I'm not going to really dig into like massive details on how to trend it because the ways in which you do it, those implementation details are so specific to you, your organization, your company, what you do, that my handing you code is just destined to have you deconstruct it, take it apart, and do a million things with it. So this is a pretty like classic get me the weight information query from SQL Server. I'm going out, I'm doing a lot of stuff here on purpose to get more information, but basically sys.dmexec requests, dmexec sessions, sys.databases, SQL text, done. So I'm really just getting information about the currently processing requests, sessions, SQL text to know exactly what's being run and the database it's being run in. Now, an important note in this data before I display it is that this data is telling you about what's currently happening. It is not saved in SQL Server forever. So when I hit F5 and run this, I see what's going on my server right now, and that's it. So I run it right now on my current local server, I see one thing going on. If I run it again and again and again, that's how it's going to be because one thing's going on in here right now, and that's me. Great. But if I stop doing things and you run your check, you won't see whatever I was doing anymore. So this is a sort of query you want to run often and then dump any unnecessary data and keep what you need to. This will get kind of large, both in terms of number of rows and width, and that may be a problem in time. But I made this query very large on purpose because I want to display just how much stuff you can get. Obviously server name, local time, but you can get session ID of the thing causing trouble. Is it being blocked? The database, the wait time, the wait resource, wait type, what's the name of your host, and lots of details, program, login, command, the actual SQL text. I can grab the first 200 characters, the whole thing, the proc source, the query hash. So really, there's just this huge, huge amount of information we can get here that is a wealth of knowledge. It truly is a wealth of knowledge. There's more columns I didn't get here because I just didn't feel like putting more stuff into this and making it even more massive and behemoth. But this is operational data, classic operational data. What I'm suggesting we do is take it, use it for operations, but don't throw it out then. Keep it forever, or at least a very long time. I say forever because it very often is a good benefit to keeping this data long term. And if you compress it and limit how much you store, keep the valuable stuff, it won't be that big. It really won't. The size of this will be small compared to the value you glean from it. So what can we do with it? It gets big, and we want to keep only the data that's relevant to us. A very common filter is only giving the scenarios where wait time is greater than 0. That is a useful way to get rid of bad stuff, but you may or may not want to do that. It really depends. Do you only care about weights, or do you care about other things as well? If you want info on your blocking process, because you're blocking, you need to also get that one as well, which may or may not have a weight associated with it. So you may or may not filter on that. It really depends on your own situation, your own code. If your data gets too big, this is a common theme, you can save only n days of data, or you can cut the string short, you can normalize it, you can column store it, compress it, however you want. You could also filter down to certain databases, applications, servers, logins, whatever, because maybe you don't care about every single thing going on in your server. Maybe you only care about the application and SQL Server agent, or SSRS and analysis services. I don't know, but you can filter. But this data provides massive use, because imagine now that I have the timestamp on here. I have my local time over here. I know when this occurred. You can UTC it if you want, datetime offset it, whatever you want. It's stored in local time in SQL Server, so do with it as you will. What can I do with it? I can sum it up over time to see aggregate weights. I can do weights by database, weights by host, program, login. If you know that the application that you work with has 3 different logins or 5 different hosts that requests come from, or it has 6 different programs, you can aggregate based on that, or just keep the raw data. Again, you don't have to keep all the raw data if you don't want to, but you can. You can keep all the detailed data for months, years, whatever, or you can aggregate it based on whatever metrics you want to aggregate by. Again, analytics ultimately says, bring it down to the form that you'll report on and keep that. So if all you care about is weights by host, dump the rest, keep what you need, call it a day. If you want weights and you want to keep the SQL text, you can keep SQL text too. That's very valuable information. Now you know what is the thing that's slow and what is it waiting on that's slow, and figure it out, and why is it waiting. So long term, you can then say, hey, I want to compare this month to last month. What changed? I want to compare pre-release versus post-release. I just released a giant pile of code. There was like 1 million lines of new stuff that went out today, and now we're running on new code. How's it going? And you can wait until people call in with problems, or you can say, hey, here's my snapshot 1 week before, 1 week after. Compare what has changed. What is there more of? What is there less of? Is anything concerning? I don't know. And you can go from there. So this is extremely useful data. And again, it's data that you think of as operational, but it really can be analytic in nature, and that's huge. So blocking weights, it's not just for monitoring anymore. It can be for long-term trending, capacity planning, finding anomalous problem bugs, app bugs, huge for that, and contention and long-term resource issues. If I want to know, am I going to run out of resources in the future, this is a good way to find out. And the 3 examples I've given so far, row counts, IO, and blocking, are intentionally very different because they can be used together. In conjunction, you grab 3 metrics like these, you can begin to take them together as aggregate and say, hey, I just noticed after a release that suddenly this week, this one table is growing by an extra 10,000 rows a day, and I don't know why. It shouldn't be doing that. I also noticed that writes in this database are up 5% every single day. I don't know why. And hey, wait a second. I noticed this one process here is waiting more than usual on this one wait resource. And hey, look, it's the table. The rows are growing. Wait a second. And you have all the proof you need now to solve this problem before somebody calls in a month and says it's slow. Cool. And of course, this is only the beginning. I gave 3 examples that may or may not be of use to you. But there are really many, many more metrics out there that you could go after. Things like job runtime, missed jobs. You can go after backup size. This is actually a big one because it's interesting. It ties into what I was just talking about. So when you take care, backups have many uses in the world of data. And in addition to point-in-time recovery, you can look at those backups to understand a little bit more about your database. You can say, hey, if I monitor my backup size, so backup size is, again, very operational data. You may look at it, you may never look at it. But one thing we do know is that if a transaction log backup size is unusually large, that means you're writing an excessive amount of data to your database. You're writing a lot of data to it over a unit time. For example, if you know that in general your transaction log backups for a database are never really more than 1 gigabyte, ever. You take your backups every hour, they're 1 gigabyte. It never goes much more than that, maybe a little, but never too much more. And then one day after release, now it's 20 gigs. You say, hey, that's strange. Or maybe it grew over time and you didn't notice it. It went from 1 gig to 1.25 to 1.5 to 2 to 3. This is the trending where you would say, hey, wait a second, this isn't right. Something's wrong here. And because I have monitoring on these backup sizes, I noticed a problem. This means that more stuff is happening, more data is being written. So this has nothing to do with reads, it has to do with writes solely, kind of like the database IO, file stats stuff. You can relate these now. You can say, I know that too much data is being written, something weird is happening, what's writing so much? And then you might eventually say, hey, we found it. there was just a new process of updating data over and over unnecessarily. It should have really just been updating it once and stopping, but by accident, I forgot to update the last modified time, and it kept updating it over and over and over ad nauseum every 1 second. Whoops, done. That's the kind of thing you might find. A bug, a problem, a thing that analytics can help track down, whereas operational data may not make it obvious till it's an emergency. And there are more ways to do research as well. So we're looking for things like, large backup sizes that are unusual. Obviously, your data log backup, your data backup size, your full backups, your diff backups, that really tells you more about your database itself. The T logs are where the action is. And that'll tell you, are there excessive writes? Are there too few writes? And that'll include updates, the thing that row counts missed. If you're adventurous, there are third-party tools out there. Apex SQL Log is one of them, but there are others. There's also internal tools like FNDB Log or DumpDB Log and so on, where you can actually analyze your log files. These aren't the most supportive things to do, but if you're in a bind and you have a backup file you can copy somewhere, out of production and play with, this is a fine way to take a transaction log and investigate and find out, well, what is the change? Because if for some reason all the rest of your analytics can't tell you, all the rest of your operations can't tell you what the problem is, you can use these tools to try to figure it out. And then once you're into the log file and digging into it, looking at all the detail, you can say, hey, I see the same thing happening over and over. I know what that is. Let's deal with it. Whoops, done. And one nice metric, too, is your ratio of database size to log size. This is the reality check in the world of databases. If my database is a terabyte and my log is typically 10 gigs, that's cool. 20 gigs, that's cool. If my log was 2 terabytes, though, something's wrong. It might have been a release that did it, a one-time event that we expect to make a giant backup. But if you have a database that is a gig, for example, your transaction log is a terabyte and growing, that means something is wrong. That means you probably don't have full backups or being run. Your T logs are just growing forever. It means it's a serious problem. So your database size versus your T log size is a nice reality check to tell you, are things normal? Is the amount of change sensible given the size of my database? Again, you can trend this all over time to know what is normal and not normal. So nowhere here am I saying yes. They can certainly play around and goof with data for fun. We all do it at some point or another for fun. That's fine. But ultimately, you can use your analytics tools to take a look at your history and say, I know how fast my data grows. I know how fast my log grows, if at all. Because again, your log allocated space should never change much. The U's will go up and down and up and down. Your T-log backups will be however big they are. That comparison is very useful. And there are many more ways to get metrics besides this. Ultimately, you can take any metric from your server, from information about your jobs, inputs, outputs, weights, blocking, all these things we talked about, or you do the custom stuff. So if you've gone through all the things in SQL Server that you measure that are useful, and you got them, and you feel good, there is more potentially because you can actually create metrics for your application. Let's say your application itself has measurements built into it as to how they perform. Things like, hey, we have an app that writes files. You could measure how fast does it write files? What's the bandwidth? What's the throughput? What's the IOPS? How large are the files on average? How many do we do over the course of a minute, hour, day, whatever? And those are custom app metrics. A custom app metric is great because you can now tailor all the other metrics we've talked about so far and link that to things that are more relevant to your application. So you're now building metrics about your app, not about SQL Server or its data, but about the application. For example, let's say you process orders online. You may be interested in the speed of those orders and the size of those orders and how fast they process, things like that. You can keep all that data and relate it back to this. Or maybe you have an analytics server that processes tons and tons of OLAP data, terabytes of it every single day, and crunches it and places it into places so you can reach out with it tools and analyze it. Well, we can measure all of that too. What's the throughput of all of that? How much data are we reading and writing every day? How fast are our processes? Are they fast enough? Are they not fast enough? How many requests are coming through for that data? How big are they? How slow are they? How good are they? How bad are they? So you have a lot of options here. When I talk about more metrics, there's really an endless list. And the list is really based on what you do and what you need. And I can give you ideas. This session so far today is about ideas. But ultimately, what you do is up to you. And it'll be different for everyone. Every single person on this session right now, including me, will have different needs for data. Some of us will say that this and this is useless, but boy, I could really use the IO stat. That's really useful. Or you might say this all stinks, but I do have things I could measure, and if I measured them and stored them and trended them over time, they might very well end up being useful, and then I can do all these things I'm talking about with that data. So ultimately, we now have data. We're throwing it into tables, and you're collecting tons of it. This data will get big. And so you have ideas for what are we going to do with this data. You may have one server, you may have many servers. So how do we manage this volume of data in a meaningful fashion so we don't go off the OLAP deep end of the pool into heck? And there are a lot of ways. These are some suggestions and best practices and ideas. There's many, many more out there. One is if you manage many, many servers, you're going to collect this data on all those servers, and you want to centralize it. My recommendation would be that collect that data locally in every server. So maybe put a SQL Server agent job or some PowerShell or whatever your preferred tool is, and collect that data on every single server you manage locally in a database for each metric you care about, and store it there. And then later on, have a central process somewhere, in your analytic world, go and reach out and grab that data and pull it back. The benefit of this is you can stage your data locally, you can filter it, you can shrink it, you can compress it and do all the things you want to do to it to make it nice and compact. You can get rid of all the fluff, the things you don't need, make it perfect. And then your central OLAP instance can then say, hey, you've filtered your data nicely. Let me grab that now and throw it into a cube or into Power BI or throw it into a column store index table so I can have a billion rows all nice and column stored. And then once your data is there in a central place, you can track those changes over time. And the goal is automate. So when you track changes over time, you're saying, give me the day over day, the week over the week, the month over the month, the 7-day moving average, the 14-day moving average. These are pretty common things. And if you're into stats, you're into data science, you have way more you can do that goes well beyond the scope of this presentation in the world of how do I analyze my data. But your goal ultimately is to find trends. Find trends, establish baselines, look for anomalies. And that's really the tactic you care about here most. And you don't have to do it all programmatically. If T-SQL is your shtick and you love T-SQL, use it. That's great. Do everything in T-SQL. If you love PowerShell, if you love Power BI, whatever your tools of choice, use it. Use the appropriate tool and make that your friend. And at the end of the day, all we're really doing here is creating a brand new data source from data, and then that becomes published and usable for analytics. So we're creating analytic data. And so we're really starting off with the world of operational data. We're moving through the world of administration and storing that, moving through the world of data architecture, we need a place to put this and a process to make that data flow appropriately there. And then into the world of analytics, where I'm going to take and analyze the stuff and figure out what's good and bad in my application and what can we do with it. And there's no limit here. You could write a 100-line SQL proc that will do all the work for you that you need to do, and life is good. Or it can be a really complicated product. You can point machine learning at this to say, hey, I want you to track my data for me, or a third-party tool, and track my data for me and look at it every single day, and then you do your magic and let me know. That is also perfectly legit. So really, this is up to you what tools you use, what processes you use, but the goal is to transform operational data into analytic data and walk that walk. And the beauty here is you're going to talk to a lot of people in the process. It is possible that you manage all the systems needed to do this yourself, but odds are you won't. Odds are you're going to have to communicate with other people out there in your world who may be developers, who may be architects, who may be analysts, who may be operations people, and learn about their systems and processes before you can ultimately do what you want to do with this data here. And that's usually a good thing, not a bad thing. And there's more. Ultimately, everything I talked about here is a puzzle piece. This data, each piece of it, every column of it, every table of it, every metric, every analytics table, every process here is a puzzle piece. And on their own, individually, they're useful. But taken together in a group, they become more. You can look for not just trends over time, but more complicated trends that link to the different kinds of data and that give me better views of it. If I were to look at just one thing like row counts, I could probably find anomalies and bad stuff and solve some problems and be a hero. But it won't tell me everything. If I were to take that data and merge it with weight data or backup size data or job runtime data where each job associates with certain tables that get dealt with in production, or releases. Suddenly I have a stack of puzzle pieces that all relate. They all have lines that go between them and tell me, hey, how does this stuff relate? If this is anomalous and this is anomalous, what does that mean? If this is anomalous, but these things over here are not, well, maybe it's okay then. I can include that in my analysis. If all of these things are bad at once, should I panic and get up in the middle of the night and do something? And the answer might be yes, or maybe it'll be no. Or maybe the answer is 9 a.m. with a coffee and fix it. But these are all puzzle pieces. So ultimately, what your really goal here is to relate all these analytics back to the application again. So you have your app, you have your operations, you have your architecture, your ETL, your analytic data, and then ultimately you learn more information about your application and provide that feedback back to your development team so they can improve their software. So you're really creating a loop here. Your puzzle pieces here are all the things along this loop that give you what you need, and then you travel this loop and you continue providing feedback, and they provide feedback to you. And one of the huge bonuses is you'll develop wonderful relationships with your other teams because you're helping them. You're helping yourself, you're helping them, you're helping everyone, and it's a really good thing. And so put together the puzzle pieces into a system that provides you the data you need, the analytics you need to trend and understand that data, and then whatever processes you need to deliver that information as needed back to those that will care about it, because ultimately it'll be application developers or SQL developers or architects, people who designed this stuff originally, whether it's you or somebody else, will care. And that really is the ultimate goal here, is put it all together and create a process to make things better so you can solve problems before they get horrible. So I'm going to start to wrap up now and kind of get to a conclusion here, at which point we can take some questions and answers. Any ideas you have, things you've done. I love hearing the ideas people have as to ways to use this, because this is very open-ended. This is not a thing where I give you one script and you run the script and it's the holy grail of scripts. This is where I say, here's some scripts that are ideas. Go mess with them, add stuff, remove stuff, break them, do your own, and then get some ideas and then come back later. And the idea ultimately is you want to improve your bug catching. You want to reduce the emergencies, reduce the capacity breaking events. You want to reduce the number of things that go wrong unexpectedly. And when you combine all these puzzle pieces together, you ultimately get your way to not only find problems before they're serious, but you can also prove it. When you have to go to somebody and tell them, hey, there's a problem here, or hey, I see a capacity issue come up. Hey, we're going to have to buy some more of this. We need more memory. Those kinds of things often require justification. If you live in a world where you can ask for resources and get it for free, all the time, no questions asked, you're lucky. But most people don't live in that world. And even if you do, being able to back up your requests with data is good. It makes you look like you know what you're doing, and it tells everyone that they should trust you and trust your data and understand your data and not think that you're just asking for stuff you don't need. And the beauty of this is you may already be getting some of this data or all of this data in a production environment, and the only additional thing you have to do is just take it and copy it somewhere to keep it for posterity. And so now you take this operational data that you have over here, you copy it here, and then it goes through that life cycle through analytics back to your teams, and it can get used. And then the biggest key here, the reason why this is awesome, is you predict problems before they become problems. Some of us may be doing this already, some of us may not be, but this is something I've personally done and gotten great satisfaction out of. I've found application bugs, before anybody else ever noticed them. Like, hey, we have this table here, and this one column in the table is beginning to get large, unusually large. Well, how did you find that? Oh, I noticed the T-log backups began getting a little big, and that was weird. I related that back to some row counts. Well, the row counts weren't getting bigger, but the data size for that table was getting bigger over time, and that seemed concerning. I didn't know why that was the case. I began looking at the app code. I looked at weights, and I found, hey, the weights have gone up on this table. Here's the code. Hey, there it is. You forgot to clear out your column. You're writing additive data, and you oopsied it. You keep adding more forever instead of clearing it out first. Whoops. So these are things that can be used in the real world. They can solve real world problems. They can find problems before they become problems and make your life easier. And there's a feedback loop. In addition to the feedback loop that you provide towards developers to fix their code and make things better, you give feedback to yourself by saying, hey, I found a new anomaly, something that's bad in here. I know that if this particular data grows too quickly, that is bad. If this general set of data, all these tables here in aggregate, grow too quickly or too slowly. I know it's bad. I learned a new thing today. I will code that and instruct my software to look for that. And so now I have bug catching for that as well. And so you provide evolution, your developers provide evolution of this, and things get better over time. So that's kind of where I'm going to stop here. I really want to open up to questions and spend a few extra minutes on questions. Feedback is very important. Please provide feedback. I want to learn more about why this is good, why this is bad. Feel free to submit feedback through the sessions themselves, through the event site, or you can send feedback to me as well. Send feedback to me via Twitter or whatever social media you prefer, and I'll listen and reply to you. I promise. I always do. It's my thing. I like replying, and that's cool. So I'm going to hand it its point back to Tayab to do the Q&A and see what Q&A there is. And if there isn't much, I'm sure you could dream of something to talk about for 15 minutes with me, because we can chat, right?